Nenomatica, where mathematics meets YouTube excellence. In this lesson, we will solve a radical equation using a geometric idea, and then confirm our answers algebraically. Here is the problem. We want to solve the equation. Square root of x plus 1 minus x squared equals 2x plus 1. Strategy. First, isolate the square root on the left. Then we will view the equation as f of x equals g of x and find intersection points on a graph. Let's draw axes and both functions on the same set of axes. Remember, the domain of the square root is x greater than or equal to -1. We now graph f of x equals square root of x plus 1, and g of x equals quantity x plus 1 squared. First f, the square root curve. Next g, the parabola shifted left by 1. The intersection points give the solutions. We see two intersections, at x equals -1 with y equals 0, and at x equals 0 with y equals, and at x equals 0 with y equals 1. So the geometric solutions are x equals -1 and x equals 0. Now let's confirm algebraically. Start from the original equation. Move x squared to the right and isolate the square root. Square both sides carefully. Simplify and factor to solve for x. Finally, check each solution in the original equation. Therefore, the solutions are x equals -1 and x equals 0. Recap. We graphed f of x equals square root of x plus 1 and g of x equals x plus 1 squared, found their intersections, and confirmed those x values by algebra. The question is, are there any real numbers x that satisfy square root of x equals x plus 1? First, the geometric method. We think of the equation as the intersection of two graphs. F of x equals square root of x, and g of x equals x plus 1. Let's draw coordinate axes. Now plot f of x equals square root of x, which starts at the origin and curves upward. Next, plot g of x equals x plus 1. A straight line with slope 1 and y-intercept 1. We'll label both graphs. Notice on the domain x greater than or equal to 0, the red line g is always above the blue curve f, so the two graphs never meet. That means there is no real x where square root of x equals x plus 1. Now, the algebraic method. Start with square root of x equals x plus 1. Square both sides to remove the square root. Expand and collect like terms. We obtain the quadratic x squared plus x plus 1 equals 0. Its discriminant is 1 minus 4, which is -3, less than 0. Therefore, there are no real solutions. Conclusion: the equation has no real solution. In this lesson, we will solve a radical equation using two approaches, a geometric or graphical method, and an algebraic method. The equation is square root of x minus 1 equals x minus 3. Here is the problem statement. We'll first visualize the two sides as functions to find the intersection, then confirm algebraically and check for extraneous roots. Geometric method. Define f of x equals square root of x minus 1 and g of x equals x minus 3. We will draw both on the same coordinate plane and locate their intersection. The domain for the square root requires x greater than or equal to 1. From the graph, the curves meet at x equals 5, y equals 2. Therefore, the geometric method suggests the solution x equals 5. Now let us confirm algebraically and also check for extraneous solutions. Start with the original equation. Square root of x minus 1 equals x minus 3. Because we have a square root, we square both sides. That yields x minus 1 equals quantity x minus 3 squared. Move all terms to one side to form a quadratic. We get x squared minus 7x plus 10 equals 0. Factor the quadratic as left parenthesis x minus 5 right parenthesis times left parenthesis x minus 2 right parenthesis equals 0. The candidates are x equals 5 or x equals 2. Every time we square both sides, checking is essential. Substitute x equals 2 into the original equation. The left side is square root of 1, which equals 1, but the right side is 2 minus 3, which equals -1. Not equal. So x equals 2 is extraneous. Now substitute x equals 5. The left side is square root of 4, which equals 2, and the right side is 5 minus 3, which also equals 2. They match, so x equals 5 is valid. Conclusion. The solution to square root of x minus 1 equals x minus 3 is x equals 5. The geometric method and the algebraic method agree. In this lesson, we will solve the equation square root of x plus 2x equals x squared plus 2 using two complementary approaches, a geometric graphing method and an algebraic method. First, isolate the square root so we can interpret the equation as an intersection of two functions. Subtract 2x from both sides to get square root of x equals x squared minus 2x plus 2. Now subtract 1 from both sides. The right-hand side becomes a perfect square, so we have square root of x minus 1 equals quantity x minus 1 squared. Think of this as two functions. Let f of x equal square root of x minus 1, and g of x equal quantity x minus 1 squared. The solutions are exactly the x-coordinates where the two graphs intersect. Let's draw the axes and the two curves. We can read one intersection immediately at x equals 1, where both sides are 0. There is a second intersection a little to the right. Solving the corresponding cubic gives x approximately 1.453. Let's mark both points on the graph. From the geometric viewpoint, the solutions to the original equation are exactly these two x values, 1 and the approximate value we just found. Now, let us confirm this by an algebraic derivation. Starting from square root of x minus 1 equals quantity x minus 1 squared, square both sides to eliminate the radical. This yields x equals the square of quantity x minus 1 squared plus 1. Expand the right-hand side. It becomes quantity x minus 1 to the fourth plus 2 times quantity x minus 1 squared plus 1. Move the x to the left to set the equation equal to 0. Factor out one copy of x minus 1. Let t equal x minus 1. Then we get t times quantity t cubed plus 2t minus 1 equals 0. So either t equals 0, giving x equals 1, or t satisfies the cubic t cubed plus 2t minus 1 equals 0, which has one real root near 0.453, giving x approximately 1.453. Always check solutions in the original equation, because squaring can introduce extraneous roots, and the domain requires x greater than or equal to 0. Both x equals 1 and x approximately 1.453 satisfy the original equation. Final result. The equation has two real solutions. Example. We will solve the equation square root of 3 times x minus 3 sine x equals 0 using a geometric approach with graphs. First, write the equation clearly on screen. Step 1. Isolate terms. Move the sine term to the right side, and then divide both sides by 3. Step 2. View this as an intersection problem. Define two functions, f of x equals sine x, and g of x equals square root of 3 over 3 times x. The solutions occur where these graphs cross. Step 3. Let's draw both graphs on the same axis and look for the intersections. First, the axes. Now, the sine curve, and the straight line with slope 1 over root 3. Step 4. Mark the intersection points and read off their x values. There are 3 solutions, one negative, one at 0, and one positive. Numerically, the negative solution is approximately minus 1.714, the middle is 0, and the positive solution is approximately 1.714. Step 5. State the solution set clearly. The equation square root of 3 times x minus 3 sine x equals 0 has solutions at x approximately equal to the negative 1.712, x equals 0, and positive 1.712. These came from the intersections of the two graphs. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. Nenomatica, where mathematics meets YouTube excellence.